So welcome to the FARA Preliminary Physics Assessment Task 2 video. And so what we're going to do now is, I'm just going to write Mr. Dodds. I'm going to take you through the answers to this assessment task. So the assessment task had 6 different sections. I'm going to go through these sections one by one and go through the answers. So if we look at question number 1, what we're focusing on here is looking at a Hot Wheels car launching horizontally from a ramp. The ramp's got a height of 0.73 meters, and the car actually lands on the ground 1.14 meters away. So the few things we need to calculate in this question are the total time of flight of the car's horizontal velocity, but then this third part of the question looks at, all right, whereabouts are we going to place a bucket to catch the car if that bucket was a little bit back from the landing ramp? So the first thing we want to do is actually write down our equations of motion. So we're going to write these up in the corner here. I'm just going to write V equals U plus AT. V squared equals U squared plus 2AS. And delta Y equals UT plus a half AT squared. So we're going to keep them up in the corner, and they're going to help us to solve this question. So the first thing we want to write down after we've done that is what actual values do we have? Well, we have the height, so we actually do have delta Y, and that equals 0.73 meters. And we also have delta X, the range, and that is equal to 1.16 meters. Now, I know that's not the same as 1.14 as it's shown in the question here, but we actually changed it to 1.16. So to calculate the time of the flight of the car, we need to use the equation delta Y equals UT plus a half AT squared. Now, because the initial velocity of the projectile in the Y coordinates is 0, we actually get delta Y equals 0 plus a half AT squared, because U initially is 0. Now we can actually rearrange this equation to get T squared equals delta Y divided by a half A. That then becomes T equals the square root of delta Y over a half A. Plugging in our values for this, we get T equals the square root of, now our delta Y, as we can see there in the question, is 0.73 meters. And obviously a half A is going to be a half times 9.8. So 0.5 times 9.8. And if we put that in our calculator, square root of 0.73 over a half times 9.8, we actually get the total time of flight, excuse me, and that time is equal to 0.3859874743. Now we're going to round that time to 2 decimal places, and it's going to be 0.39 seconds. And just so we don't lose ourselves in our working out there, I'm just going to highlight that. And once we've done that, we should write that in our answer up here, 0.39 seconds. Excellent. So now we're going to focus on the next part of the question, which is calculating the horizontal velocity. So UX, the horizontal velocity, is simply distance divided by time, which is equal to 1.16 meters divided by 0.39. And if we plug that in our calculator, 1.16 divided by 0.39, we get 2.974358974. Once again, rounding to two decimal places, we're going to go 2.97 meters per second. Once again, we don't want to lose what we're doing here, so we're going to highlight that. We're going to come back up here and we're going to put that answer in, 2.97 meters per second. That's its horizontal velocity. Now, for the purpose of this question, I'm going to bring the bucket back 30 centimeters from the finish. And so the equation we're going to have to do here is calculate the new time. So I'm just going to jump in here. All right. Calculating new time. And to do that, it's actually quite simple. We're actually going to get what the projectile used to go, which is 1.16 meters, and take off 30 centimeters. So we're going to go 1.16 meters less 0.3 meters equals, and the answer is going to be 0.86 meters. So that's our new range. To find the time, we just simply get the distance that we want the projectile to go divided by the velocity, which is 0.86 meters divided by, now because horizontal velocity is constant, we're just going to go divided by 2.97 meters per second. Put that in our calculator. And our new time there is 0.289 blah, 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 which will round to 0.29 seconds. So that is our new time. From our new time, we need to calculate our new height, which is the height the projectile will fall in that time. So what we're going to do now is we're going to go delta y equals ut plus a half at squared. Now we already established at the start of the question that u is 0. So we go 0 plus a half times 9.8 times 0.29 squared. And if we put that in our calculator, we go 0.5 times 9.8 times 0.29 squared. We get 0.41209 meters. So the projectile will fall that far. Now we need to be careful here because the projectile is falling that far, we actually need to then take that off the initial height, which is 0.73 meters, to actually find the height of the bucket above the ground. So we're going to go 0.73 minus 0.41209 equals, and we get 0.31791 meters, which we're going to round to 0.32 meters up. So the bucket's going to be 32 centimeters off the ground there. So we're just going to highlight that answer, and there we go. So that's question 1 fully worked out. Hopefully you get the car in the bucket. We're now going to move on to question 2.